What up, Kim2? So here, now that we've established what equilibrium is, what the equilibrium constant is, we're now going to look at a couple different reactions. And we're going to write the equilibrium constant and so on and so forth. But I want to talk about this reaction right here. So this is Fe with a positive 3 charge in solution reacting with what's called the thiocyanate ion, and it forms this really complex FeSCN2 plus ion, and it's an equilibrium system. One thing about this reaction is to know that it is exothermic because it has plus heat over here. The other thing that you may be wondering is, I've never seen this thing in my life before. What on earth is it? Well, when we do equilibrium studies, oftentimes we want to focus on which particles are more predominant, either the products or the reactants. And one of the easiest ways for us to do that is to look at color. And so if something becomes darker red, then we know that there's more of this FeSCN positive 2 ion. But if it becomes more yellow, like pale yellow, then that means there was an increase in the positive 3 iron. And so therefore, we can easily tell whether there is a shift in the equilibrium towards the products or the reactant. So the first thing that you're going to do is write the equilibrium expression for this reaction. No big deal. But then what you're going to do is you're going to look at all these different stresses that we can put on this system. So we've got this test tube of these ions in solution, and it's a mixture of iron 3 positive, the thiocyanate, and the FeSCN positive 2. So it's a balance between those guys right now. So then I can put in a certain stressor. Like, for instance, I can hold it over heat. And if I click this button, like so, then what I see here on the left was what it was originally, and this is what it was after I heated it. So when I heat it, it becomes more yellow. Well, what does that mean? To get back to the original, all I have to do is hit back. When I heated it, it became more pale yellow. And so in other words, there was a shift in the equilibrium towards the iron with a positive 3. In other words, this is what we would call shifting left. So we shift left. So you're going to now do this with all these different stressors here. So like you can click adding this guy, this guy, this guy, so on and so forth. One thing that I will say that is this: there's always notes on these that are fairly important to read. But basically what you're going to do is you're going to go through the ones that I want you to do, and you're just going to record the results. And then I'll ask you some questions. Those questions you may or may not know the answer to. You may feel confident, you may not be. But what I would like to do with this Chatlier's principle is introduce the idea of introducing stress to an equilibrium system, and then the next day actually talk about it, and then we'll be done with equilibrium and we'll be ready for acid and bases. So that is it.